Welcome to the official podcast series by POTENZA, where innovation meets insight. In this series, we dive deep into the world of SAP, explore the power of robotic process automation, and unlock the true potential of data analytics. Whether you're a tech enthusiast, a business leader, or just curious about the digital transformation shaping our world, you're in the right place. Tune in, stay curious, and let's explore the future of enterprise technology together. Don't forget to subscribe and follow us on YouTube for more powerful insights. Now, let's get into today's episode.
Imagine you are standing in the red dirt of the Australian outback. You're looking at a multi-million-dollar mining operation.
Just a massive, sprawling site.
Exactly.
Yeah.
Massive autonomous trucks are hauling iron ore, conveyor belts are roaring, and money is literally being pulled out of the earth by the second.
Right.
But then suddenly, the entire operation grinds to an absolute dead halt. The trucks stop. The ore stops moving. Millions of dollars begin vaporizing by the hour.
A total nightmare scenario.
And the culprit. A brand new state-of-the-art software system sitting in a pristine air-conditioned tower in Sydney just tried to talk to a 20-year-old server buried out in the dirt, and it failed. Welcome to the deep dive.
You know, that scenario is playing out a lot more often than you might think.
Really?
Yeah, today we are pulling our insights from a strategic advisory guide by POTENZA, and their research focuses specifically on SAP integration challenges in Australia.
Okay, so a very specific geographic focus.
Exactly. They look at what happens when these two wildly different technological eras are forced to communicate. And, I mean, the stakes are just incredibly high.
The mission of our deep dive today is to explore why connecting old technology with new technology is actually a massive strategic business initiative.
It's definitely not just a side project.
Right. We aren't just talking about a back-office IT project where someone plugs in a few cables and, updates some software. We're talking about the invisible digital backbone of the companies you and I rely on every single day.
The systems that handle our goods, our services, and even our financial security.
Okay, let's unpack this. Because to a layperson, it sounds like trying to get a brand new smartphone to seamlessly share data with a 20-year-old fax machine.
That is a very good analogy.
Right. Like, why are we even trying to do this? Why not just throw the fax machine out and buy everyone new smartphones?
Well, throwing away that fax machine would likely collapse the entire business overnight.
Wait, really? Collapse the business?
Oh, absolutely. You have to remember that these legacy systems are not kept around out of sheer corporate laziness or, an unwillingness to spend money.
So they aren't just holding on to them because they're cheap?
Not at all. They represent massive long-term capital investments. If you look at the code running these older systems, you are looking at decades of incredibly complex, fine-tuned business logic.
Like a highly specialized corporate DNA almost.
Precisely. It's customized to keep that specific company alive. They contain functionality explicitly tailored to Australia's unique geography and compliance frameworks.
Okay, so geography actually plays a role in the code.
Yeah, the POTENZA guide gives some excellent, very specific examples of this. Let's go back to that mining operation out in the remote Pilbara region you mentioned.
Right, the autonomous trucks in the dirt.
Those trucks drive down into deep pits where there's absolutely no cellular or Wi-Fi coverage. Zero.
So they're just completely cut off from the network.
Exactly. The local 20-year-old legacy system was specifically designed to handle extreme connectivity constraints.
Oh, I see.
It allows the trucks to collect data completely offline all day, and the second they drive past a specific checkpoint with a local network, it instantly bursts that data to an on-site server.
Which means a global software company building an out-of-the-box cloud system in Europe or the US probably wasn't thinking about how a truck operates with zero internet connection for a 12-hour shift at the bottom of a hole.
And that right there is the crux of the issue. The same goes for massive agricultural enterprises in rural Queensland or, complex logistics networks.
Networks that have to track a single pallet of goods across the entire Australian continent.
Exactly. These older systems were built locally, often by specialist engineering teams, to solve highly localized problems.
So if you rip out that mining operational system that perfectly tracks ore movements offline, and you replace it entirely with a shiny new global cloud system, what happens?
Well, the new system constantly pings the truck looking for a real-time internet connection.
And there isn't one.
Right. The connection times out due to latency, the system throws an error, and the mine stops.
Wow. You literally shut down the revenue stream because the new software panicked when it lost a signal.
Which is exactly why replacing these highly tailored systems outright carries enormous risk, both operational and financial.
It's too dangerous to just rip and replace.
Therefore, integration is the pragmatic path. It is about preserving that local, highly customized machinery that works flawlessly in the dirt.
While also getting the benefits of the new stuff.
Yeah, connecting it to the modern analytics, reporting, and speed that a platform like SAP provides in the boardroom.
I hear you, but I have to play devil's advocate for a second.
Go for it.
Isn't holding on to this old tech just delaying the inevitable? It sounds like putting a fresh coat of paint on a crumbling house.
It can definitely look that way to an outsider.
Like, how long can you realistically duct tape these two worlds together before the entire structure just caves in on itself?
Well, if we connect this to the bigger picture, it is not duct tape if it is architected correctly. It is about interoperability and sophisticated risk management.
Okay, but what about the crumbling house analogy?
To use your analogy, you don't demolish a house if the foundation is exactly what you need to weather a localized, very specific type of Australian storm.
You keep the foundation.
Right. You reinforce that foundation, and you build modern capabilities like solar panels or smart thermostats on top of it.
So it only becomes a duct tape situation when organizations do it badly.
Exactly. It fails when they aggressively ignore the deep incompatibilities between these systems.
So if we agree that we have to keep this tailored Australian house foundation, but we are forcing a hyper-fast European cloud roof onto it, where does the structure actually crack under the pressure?
Well, as POTENZA points out, these incompatibilities aren't just superficial. The IT landscapes of most medium to large Australian enterprises are heavily fragmented.
Meaning they aren't just one clean system to begin with.
Right. If you look under the hood, they haven't been built according to a single, coherent master plan. They are patchworks.
How does a company end up with a patchwork system?
Imagine you run a business, and over 20 years, you acquire 3 competitors. You inherit all their tech. Then your marketing department builds an in-house tool.
And suddenly you have this Frankenstein IT department.
Yeah, suddenly you have modern cloud applications, on-premises servers locked in a basement, and software running on hardware that the original manufacturer hasn't supported in half a decade.
And then you decide to drop a massive, modern SAP system right into the middle of that patchwork and expect them all to hold hands and sing.
You immediately hit a massive language barrier. You are dealing with entirely different eras of computer architecture.
Right.
Modern systems like SAP are built on APIs and microservices.
Let's translate that for the listener. When you say APIs and microservices, what does that actually look like in practice?
Think of it like a continuous, fluid text message conversation. Modern systems expect to be able to ping each other constantly.
Asking for tiny pieces of information in real time, right?
Yes, and getting an instant reply. Legacy systems, however, often rely on something called batch processing.
So they don't do real-time text messaging.
Not at all. Instead, they save up every single piece of data they collect all day long, pack it into one massive digital box, and send it over in one giant chunk at exactly midnight.
So you have one system trying to have a rapid-fire text conversation, and the other system is essentially filling up a heavy shipping container, locking it, and putting it on a train once a day.
That is the perfect way to visualize it.
I can see why they wouldn't understand each other. And the source guide gets really specific about this technological language barrier, too.
Oh, it lists an absolute alphabet soup of protocol.
Yeah, it says SAP speaks languages like RFC, IDOC, BAPI, REST, and OData.
Meanwhile, the legacy system is sitting over there communicating via SOP, or dropping FTP files, or using direct database connections.
It is the equivalent of putting an English speaker and a Mandarin speaker in a room, giving them both megaphones and telling them to negotiate a complex legal contract.
Exactly. And even if you manage to build a technical translator between those protocols, you run headfirst into the next massive structural crack: data silos. This is where the human element of bad data entry over 20 years comes back to haunt you.
Oh boy. Give me an example of how that breaks the integration.
You encounter the classic 5 different date formats problem.
5 different formats.
Easily. Let's say a customer ordered something on the 10th of December, 2026. One legacy system records that as day, month, year 10/12/2026.
Okay, standard Australian format.
But another system inherited from a merger uses month, day, year 12/10/2026. Another uses a two-digit year.
Oh, I see where this is going.
Yeah, so if you just wire these systems together without translating the underlying meaning of the data, the shiny new SAP system scoops up 10/12/2026,
And it misreads the delivery date of December 10th as October 12th.
which means a massive pallet of perishable goods either sits on a loading dock for 2 months rotting, or it gets shipped out 2 months early and rejected by the customer.
Yikes. That is an expensive misunderstanding.
And the most terrifying constraint in all of this is what Potenza calls the live system constraint.
Right, because you can't just pause a global business to fix this stuff.
Exactly. You are often integrating these legacy systems while they are running critical business functions that absolutely cannot be switched off for maintenance.
So we're talking about live production lines or high-volume financial reconciliation systems handling millions of dollars a minute.
Yes.
Here's where it gets really interesting. So mapping this data is essentially like trying to rebuild an airplane engine while the plane is flying at 30,000 feet.
That airplane analogy is entirely accurate, and it's the exact reason why integration is so fragile.
Because if you can't turn the system off to connect it, how do you map a process dependency without accidentally shutting down a whole warehouse?
Well, if you take a wrench to an engine on the ground and make a mistake, you'd just try again tomorrow.
Right.
But with these live system constraints, making a mistake while integrating a live financial system doesn't just throw an error code on a screen, it grounds the plane. It literally stops a live production line.
Wow.
This is why the absolute foundational step before a single line of code is written is mapping every single system dependency.
You have to draw the entire blueprint of the flying plane before you even think about touching a wrench.
You need to know exactly what upstream systems feed data into the legacy system and what downstream workflows rely on its outputs.
Because everything is interconnected.
Right. If you unplug a seemingly useless cable, you might accidentally cut the feed that prints the shipping labels in a warehouse 3 states away.
And because that environment is so fragile and those mismatches in language and architecture are so severe, we see a lot of these projects crash and burn.
A lot of them.
So let's look at how things go wrong. The guide lays out some very clear failure patterns, and it seems like the traps are everywhere.
The traps are mostly strategic, actually, not technical.
Interesting.
The number one cause of failure, according to Potenza, is lacking a business-led strategy. Organizations get excited about the shiny new technology.
I mean, who wouldn't? It's new and expensive.
True. But they jump straight into evaluating middleware platforms or debating API structures before they have even asked the basic human questions.
Questions like what?
Like, what does success actually look like for our company in 12 months? Which specific business processes are causing our employees the most pain right now, and how do we connect those first?
So imagine you are the CEO of a mid-sized logistics firm. You just spent $10 million on SAP.
Right.
Your instinct is to treat it like an IT shopping spree, where you demand your tech team plug everything in tomorrow instead of treating it as a careful business transformation.
And that leads directly into the second massive trap, the Big Bang approach.
The Big Bang.
This is when an organization decides to integrate absolutely everything all at once. They treat it as a one-time massive project with a fixed end date.
Ooh, that sounds risky.
Friday, we run on the old systems. Monday, we flip a giant switch and run on the fully integrated new systems.
Which sounds terrifying.
It is a recipe for disaster. Businesses are living organisms. Requirements change, tax laws change. SAP releases constant cloud upgrades.
So you can't just set it and forget it.
If you don't treat integration as a continuously maintained capability, like a muscle you have to constantly exercise, it rots the moment you flip that switch.
And then there's the over-customization trap.
Oh, definitely.
This happens because platforms like SAP are incredibly flexible, right? The IT team gets a request from a department head for some bizarre, highly specific edge case workflow.
And the tech team wants to be helpful, so they say, sure, we can write a bunch of custom code to force the system to do that.
But then fast forward 3 years, that original IT team leaves for other jobs.
Yep. And the new team looks at the code and has absolutely no idea how it works or how to fix it without breaking the rest of the system.
The architecture becomes incredibly brittle.
It does. But beyond the technical and strategic traps, there are severe hidden Australian-specific risks mentioned in the guide that listeners really need to understand.
Let's get into those.
Data integrity failures are a huge one.
How is a data integrity failure different from a regular system crash?
Unlike a system crashing where the screens go black and everyone in the office knows there's a problem, data integrity issues are completely silent.
Silent. That's scary.
You might have slightly inaccurate data flowing between the legacy system and the new SAP environment for months. The systems are talking, but they are lying to each other.
And nobody notices.
It is totally invisible until you get hit with a sudden financial audit, or until you realize your compliance reporting to the government is entirely wrong.
And compliance in Australia is no joke. The guide specifically calls out the Privacy Act, 1988, the APRA Standards for Finance, and the Security of Critical Infrastructure Act.
Very serious legislation.
Let's break that down for the listener. How does a botched integration actually trigger a legal nightmare?
Let's say you have an old legacy HR system that dumps a raw, unencrypted text file of employee details, including bank account numbers and home addresses, onto a server every night.
Okay.
In the old days, that server was physically locked in a basement, so it was relatively safe. Now, your new SAP cloud system scoops up that file to process payroll.
Uh-oh. I see where this is going.
If that integration pathway isn't properly secured and encrypted during the transit, you have just exposed highly sensitive personal data.
You are immediately in violation of the Privacy Act.
Exactly. You can't retrofit compliance after the fact. If APRA finds out you are moving unencrypted financial data between systems, the fines are astronomical.
I have to ask, though, if businesses are dropping millions of dollars on SAP to solve these exact problems, why does the guide list ignoring the users as a massive failure pattern?
It's a great question.
Are tech teams just assuming the new SAP system is so magical that it doesn't need explaining to the people actually using it?
This raises an important point. It really highlights the danger of the technology-first mindset.
Right.
When a project is entirely driven by the IT department, success is defined purely in technical terms. The IT director says the API is functioning, the systems are passing data, project complete.
But the workers are the ones dealing with the fallout.
Exactly. To the warehouse worker holding a scanner, success is, I can process this pallet of goods faster than I could yesterday.
So if the new integrated workflow is technically brilliant, but requires that warehouse worker to click through 5 new drop-down menus instead of just scanning a barcode twice like they used to,
They will abandon it. They will find manual workarounds. They will start tracking numbers down on sticky notes.
just completely bypassing the million-dollar system.
Yes. Integration that serves the technology alone will ultimately be rejected by the workforce. Integration that serves the business and the actual human beings running the business will evolve and succeed.
Okay, so we have established that the stakes are incredibly high. The risks are immense, the compliance fines are terrifying, and the traps are deeply psychological as much as they are technical.
It's a lot to manage.
Anyone listening to this who is about to undergo an ERP transformation is probably sweating a little bit right now.
I wouldn't blame them.
So let's pivot to the lifeline. Potenza outlines a blueprint for survival. How do companies actually escape this chaos?
The first rule, and perhaps the most vital step any organization can take, is clean your data first.
Clean the data.
Never, ever populate a shiny, expensive new SAP environment with dirty data from a legacy system.
Garbage in, garbage out.
Precisely that concept, but on a massive enterprise scale. Imagine pouring sludgy, contaminated oil into a brand new Ferrari engine.
It would destroy it.
You have to fix the duplicate customer records, standardize those missing date fields, and establish strict data governance rules before the two systems are ever introduced to each other.
That makes total sense.
If you migrate the mess, you instantly undermine all user confidence in the new system. The moment an executive sees a duplicated invoice in the new SAP dashboard, they will stop trusting the multi-million-dollar software.
Yeah, the trust is gone immediately. What's the second rule?
The second major rule is to use proper middleware. We talked earlier about the severe language barriers between systems. You have to stop using point-to-point connections.
For the listener, what exactly is a point-to-point connection? Is that like building a custom dedicated wire between every single application in the building?
It is exactly like that. Imagine 50 people in a room who all speak different languages, trying to talk to each other by stringing individual tin can telephones between every single person.
Oh, that sounds chaotic.
If you have 50 systems, you end up with hundreds of custom wires crisscrossing the room. It becomes a completely unmaintainable spaghetti architecture.
I can visualize that.
If one system gets updated, you have to find and replace 50 individual wires.
So what is the alternative to the tin can telephones?
Businesses need to utilize modern integration platforms. Middleware like SAP Business Technology Platform, MuleSoft, or Dell Boomi.
Okay.
Instead of hundreds of wires, every system connects to one central platform in the middle of the room. That middleware acts as a universal translator and central switchboard.
Oh, that is so much cleaner.
The legacy system sends its heavy batch file to the middleware. The middleware opens it, translates the data, repackages it, and streams it to SAP as a fluid text message.
Okay, so we have clean data, and we have a central translator.
Yeah.
What about the big bang trap we discussed earlier?
Right.
How do you tell an eager CEO that they can't flip the giant switch on Monday morning?
By adopting a phased approach, you don't try to boil the ocean. You look at the business and identify the high-priority touch point.
Like the most critical workflows.
Exactly. The specific workflows that will deliver the most immediate, tangible value to the employees or the customers, and you integrate those first.
That seems a lot safer.
You build confidence, you prove to the board that the middleware works, and you create momentum. Selective integration, executed perfectly, is vastly superior to a massive, delayed, incredibly risky, all-at-once launch.
The guide also mentions being smart about real-time data, which I found slightly counterintuitive.
Oh, how so?
Because if you look at any billboard or commercial for modern cloud technology, real-time everything is the entire sales pitch. Why hold back?
Because not everything needs to be real-time, and real-time is expensive.
Oh, I hadn't thought about the cost.
Do you need customer e-commerce transactions, financial reconciliations, and live warehouse inventory to be real-time? Yes.
Right.
If someone buys the last pair of shoes on your website, the warehouse needs to know instantly so they don't sell it to someone else. But does the legacy HR system need to sync an employee's annual leave balance to the central database every millisecond of the day?
Definitely not. No one is tracking vacation time by the second.
Exactly. A simple nightly batch process, that heavy shipping container sent at midnight, is perfectly fine for that.
So what does this all mean? It sounds like you're saying we shouldn't spend millions of dollars building a massive, brightly illuminated 10-lane tollway if a simple dirt road does the job perfectly well for certain background processes.
That is precisely the takeaway. Over-engineering your architecture accumulates massive, unnecessary maintenance costs.
Right.
Every real-time API connection you build has to be monitored, secured, patched, and maintained by a human being. The simplest maintainable architecture that meets the actual requirement of the business is always the winner.
That makes a lot of sense.
And that ties directly into the final best practice design for scale and continuously monitor. You have to look at the architecture you are building today and ask, will this central switchboard still function when our business acquires 2 more companies and is twice its current size?
And you have to document everything.
Yes.
So that when the current IT team inevitably moves on to new jobs, the institutional knowledge of how that switchboard works isn't completely lost.
Absolutely. Plus, having that continuous monitoring catches those silent data degradation issues we talked about earlier.
Right, the silent failures.
It alerts you the second a date format gets misread, long before it ends up in a government auditor's report.
Monitoring ensures that the digital foundation you have built remains solid, even as the business environment inevitably shifts and changes around it. Well, this has been an incredibly eye-opening look under the hood of the corporate world. To summarize what we've unpacked today, SAP integration isn't merely an IT headache that gets delegated to the server room and forgotten about.
Not at all.
It is the very backbone of business success. If you do it poorly, you get disconnected processes, corrupted data, massive compliance fines, and frustrated employees inventing manual workarounds with sticky notes.
But if you do it right, with pristine data, a phased approach, and a relentless focus on actual business outcomes, it enables genuine, scalable transformation.
It allows these complex Australian organizations to leverage their unique, hard-won operational history, that localized DNA, while still stepping fully into the speed and power of the modern digital economy.
It really does.
And for you listening, even if you aren't an enterprise software architect writing the code, understanding this deep dive explains so much about our daily lives.
Yeah, think about the digital tools you use at your own job.
Exactly. It explains why some applications flow seamlessly and make your day effortless, while others force you to copy-paste the exact same information into 3 different uncooperative screens.
You are actively experiencing the success or failure of someone's integration strategy.
Which leaves us with a fascinating paradox to consider.
It does. We spend all this time, all this money, and all this immense strategic effort figuring out how to make today's cutting-edge SAP talk to stubborn, 20-year-old legacy systems.
Right.
But technology never stops moving. It really makes you wonder, in another 20 years, will today's shiny, state-of-the-art SAP S/4HANA become the stubborn, deeply embedded, impossible-to-remove legacy system of the future?
Oh, wow. And will a whole new generation of workers be sitting around a table, pulling their hair out, trying to figure out how to integrate our current cloud systems with whatever quantum AI-driven technology comes next?
It is almost guaranteed. We are just building tomorrow's legacy systems today.
What a thought to end on. Thank you all for joining us on this deep dive. Keep exploring the invisible systems that run our world, and we'll catch you next time.
That's a wrap for today's episode of the POTENZA podcast series, where we decode SAP, automate with RPA, and analyze with precision. We hope you found today's conversation insightful and inspiring. If you enjoyed the episode, make sure to like, share, and subscribe to our YouTube channel, and stay tuned for more deep dives into the technologies transforming tomorrow's enterprise. Got questions or ideas for a future episode? Drop them in the comments. We'd love to hear from you. Until next time. Thank you.